Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side. So in this video we're going to discuss the question trail of ones. Okay, so what does the question say? The question says that the input provided to you is n. N is an integer. N is an integer. So suppose your n is equals to 3. Suppose your n equals to 3. Now you have to tell me the number of binary strings. Number of binary strings. First of all, what do I mean by binary string? A string formed out of 0 or 1 using as a character, right? A string containing only 0, containing 0 or 1, nothing else, right? 2 cannot occur, minus 1 cannot occur, 3 cannot occur, anything else cannot occur, only 0 and 1, okay? Number of binary strings which contains at least one pair of consecutive ones. One pair of consecutive ones. Ones means this one, like the bit is set there in layman terms, right? So for example, if I take a 3, if I take 3, that means I have to form a string length of 3. So string length is 1, 2, 3. Now I have to fill it out such that there is at least one pair of 1, right? So I can fill it out in this condition as well. So if I fill out all of them as 1, it is one of the example. Other example can be 1, 1, 0. It is also valid because you can see 1 and 1 are consecutive. 1, 2, 3. If I fill it 1, 1 here and 0 here, it is again consecutive. Now, no matter of fact, nothing else is possible in this case without these three. For n equals to 3, only these three are possible. So for n equals to 3, my answer would be 3. You can do it for n equals to 4 as well. Let us try doing it. I know it will take some time, but let us try doing it. So 1, 2, 3, 4. Okay. Now, I can fill out all 1, 1. I can fill out two ones, 0, 0, 1, 1, or 0, 1, 1, 1, 0, or I can fill out 0, 0, 1, 1, right? I can continue by saying 3 with 1, 2, 3, 0, 0, 1, 2, 3, right? This is also a valid pattern. Now, is there any other valid pattern right now? So I'm not able to figure it out. Yes, there is. I can say 1, 0, 1, 1, right? I can say 1, 1, 0, 1, right? Okay. I guess there are more patterns, but I'm not able to figure it out right now. It might be possible that these are the only patterns, right? So you have to form patterns. You have to return me the number of such patterns. You have to return me the number of such patterns. Now, how will you solve it? How will you solve it? Right? You have to return the number of such patterns. Now, my basic need is the number of such patterns. So what will you do? You will apply recursion. You will apply recursion. Why? You will explore all the cases. You will explore all the cases. Right? What will you do? Right? Suppose I give you a string. I give you a string. Right? And I say its length is less than n. Its length is less than n. Then there is capacity for you to add something to string. You can add something to string. You can add something to string, right? This is also correct. Now what will you do? There are two options. You can add 0 or you can add 1. Let us say you try both. You can add 0 as well, you can add 1 as well, right? And whenever the string length becomes n, in that case, what will you do? You will say check check if it contains at least one pair of consecutive ones, at least one pair of consecutive ones, and then if it is true, then answer plus plus, answer plus plus. So what I am doing is I'm making a tree something like this. Suppose I want my n equals to 3, my string length equals to 3. I will be starting off with 0 index with an empty string, right? Now because the string length is right now 0, so I will be doing two operations. I can either add 0, I can either add 1. If I add 0, it will become 1, 0. If I add 1, it will become 1, 1, right? This is just the length of the string. 1 is length of the string, 0 is length of the string, right? Okay. If I move forward, there is again a capacity of going for 0, 0 or going for 0, 1, right? Similarly here, going for 1, 0 or going for 1, 1, right? Okay, moving on. Again a capacity of 3, 0 0 0 or 3 0 0 1, right? Now again a capacity 2 0 0 1 0 and 2 0 1 1. For 2 or for what this one 2 1 0 0 2 1 0 1, again 2 1 1 0 and not 2, it is 3 here, 3 all the way, okay, 3 3 3, again 3 1 1 1. Now these are the final strings with me, these are the final strings with me. What I can do is, after reaching these strings, what will I do? I will just run a loop. I will just run a loop for the string length, that is for I equals to 0 up till n minus 2. Why n minus 2? Because I want to compare it with the next one. So if s of I equals to 1 and s of I plus 1 equals to 1, in that case what will you do? You will say answer plus plus and you will just break out of the loop, right? Now this will be your base case, right? So my recurrence would look something like this. So I will be taking a helper function, and helper function will take my string, current string, only that is needed, and with value n, which I have to compare it with. So if s dot length equals to n, that is I have to write down the base case. So I will write down the for loop as it is, right? And now in the case of answer plus plus, I will say return 1, right? And I will just end the loop. Otherwise I will say return 0, right? Okay, in the recurrence case, what will I do? I will call the helper for s plus 0, n will remain same because n is the comparing value, and helper for s plus 1, n will remain same, right? And this will be, I suppose a is equal to b is equals to, and I will be returning a plus b, I will be returning, that's all, right? This is my whole recurrence code. But there is still some difficulty here. What is a difficulty? The villain of the DSA, or I can say the goodwill of the DSA that tries to push us more. So time complexity. What do I do by time complexity? What is the time complexity right now? So actually, what I'm doing is I'm filling n positions with either 0 or 1. So this position has two options. This position has two options. This position has two options. So what I'm doing is 2 into 2 into 2 up till n times. So that is 2 into n times. Time complexity is 2 to the power n, 2 to the power n. That is not a good approach, right? That is not a good approach, because I don't want exponential time. See, whenever I require number, try to do it in not in an exponential time, whether apply dp to it, whether anything to it, but 2 to the power n is only acceptable when you have to provide me the strings. If the question asks me that please provide the strings which has consecutive ones, then I will be happy with the 2 to the power n approach. But right now I just want the number, so I'm not happy with the 2 to the power n approach. I will like to optimize it. So let us hear the optimized version of it. What is the optimized version of it? And believe me, you will love it if you understand it, right? Optimized. I am saying that I want to find number of sequence with consecutive 1. This is my demand, right? Let us name it as x, right? If I say I know the total number of sequences, what are the total number of sequences? Just explore. Total number of sequences are 2 to the power n. Total number of sequences is equals to 1 left shifted by n. This is also equals to the power n only. That is why I am writing 1 left shifted by n. Now, can I say number of sequence not having consecutive ones? Not having consecutive ones. What is this? Let us say this is y. Can I say x plus y equals to 2, x plus y equals to 2 to the power n? X plus y equals to 2 to the power n. Can I say this? Can I say this? Take a moment, and I am saying not having consecutive and having consecutive will give me a sum of 2 to the power n, that is equal to total sequence. Why? Because these two are mutually exclusive. These two are mutually exclusive. This is, if I treat it in the set theory as this as A, then this is A complement, right? So I am saying that I am having difficulty finding the number of sequences with consecutive ones. So what can I do? I will say let's find y. My algorithm will be let's find y not having consecutive ones, and then your answer will be 2 to the power n minus y. Okay, you have to find y and your answer will be 2 to the power n minus y. Now again there is a problem, how to find y also, right? Y is also not a cakewalk, right? Believe me, it is a cakewalk. If the problem is saying easy, GFG says that this problem is easy, then we will doing it easily. Now, what I am saying is that for a string, there are two options. Two options. What are two options? End at 0, end at 0. That is the last element of the string is 0, or end at 1. End at 1, right? So what I'm doing is I'm trying to create two arrays. Suppose this is my array A, this is my array B, right? Array ith element will represent number of strings of length I plus 1, because that I will be I plus 1, right? Now of length I plus 1 ending at 0 without consecutive ones, right? Similarly, b of I will be equal to same string, same line, same line, same line, same line, only one will occur. Number of strings of length I plus 1 ending at 1 instead of 0, ending at 1 without consecutive ones. Okay, so now what will I do? I have an array of A and array B, right? I want a length of n, so I will be going up till index n minus 1, right? Because I plus 1 is the length at the index I, so I will be going up till n minus 1. That is, I want the array size A dot size equals to b dot size equals to n, right? So suppose let's start solving for 4. Suppose n equals to 4. N equals to 4. I will create two arrays A and B. A will be looking something like this: 1, 2, 3, 4, and B will be looking something like this: 1, 2, 3, 4. Okay. Now, what is the base case? A of 0 and B of 0. What is the base case? See, I want the length of this. I want the answer in this. Let us start with the basic case for A equal to 0, B equals to 0. If there is a string, can I say A0 equals to, like, if I want to fill it, no consecutive zeros. It is ending at 0. It is ending at 0 and there is only one position. I fill it with 0. Does it contain any consecutive ones? No. So what is the answer? A0 is equals to 1. Similarly, B0 equals to, I have to end it with 1, I end it with 1. Is there any consecutive one? No. So I will fill it with 1. I will fill it with 1. Now, this is I equals to 0. Coming to I equals to 1. Coming to I equals to 1. Now, I can say that if dealing about A0, now I know that AI minus 1 does not have any consecutive ones, so if I add a 0 to any of the string of the AI minus 1, I can say this is also correct. If what I'm saying is, I can add any, I can add 0 to any substring, to any string of AI minus 1, which is included in the answer of AI minus 1, and I will not receive any error, and I will still be valid. What do I mean by valid? I mean by valid is it does not contain consecutive ones, right? Now, what I am saying is, so A of I is equals to A of I minus 1. But wait, can I consider B of I minus 1 as well? So suppose there is a string which does not contain consecutive ones, right? So suppose a string is 0, 0, 0, 0, 1. Now it is my choice if I have tried to apply 0 here. If I apply 0 here, it is not consecutive right now also. It is a valid string right now also. So what I will do, A of I equals to A of I minus 1 plus B of I minus 1, right? So what A of I minus 1 will, A of I, that is, this will become 1 plus 1, which is equals to 2. Now, what about B of I? Right? So suppose A of I is equals to 0, 0, 0, 0, 0, or actually 0, 1, 0, 1, 0, right? This is A of I minus 1. This one is a string of A of I minus 1, right? Ending at 0. Now, what about B of I minus 1? It will be looking, every string including the B of I minus 1 will be looking something like 1, and I don't care what is there. It is obviously true that it is a valid string, but B of I said I have to end the string with 1, right? So if I apply a 1 here, it will no longer remain valid because these two are forming a consecutive pair. These two are forming a consecutive one pair. So what will I do? B of I is only equals to A of I minus 1. P of I is only equals to A of I minus 1. Why? Because if a string is ending with 0, this is a valid path. If I apply 1 here, it is still a valid path. Okay. So B of I equals to b of I equals to a of I minus 1, right? This is the only thing you have to do. Now, b of I will be 1. 2 plus 1 gave me 3. 2 will come here. 3 plus 2 give me 5. And 3 will come here. Now, valid sequence ending with 1, valid sequence ending with 5. Now, total number of sequences 2 to the power 4. Total number of sequences 2 to the power 4. We discussed it, right? 2 to the power 4 equals to 16, I guess, right? Okay. Now, I have strings does not contain consecutive ones as 5 and 3. That is total number of strings. That is why here is 5 plus 3. So, what is my answer? If my answer is 16 minus 5 minus 3, which is equals to 8, right? So what did we do? Let me write down the pseudocode for that. What did we do? We created an array of size n filled with zeros. Similarly, b of size n filled with zeros. Now, a of 0 equals to 1, b of 0 equals to 1. Now, for I equals to 1 up until n minus 1, what will you do? A of I equals to a of I minus 1 plus b of I minus 1. Similarly, b of I equals to b of I minus a of I minus 1, sorry, right? These array will get filled. Now, just return 1 minus a of I, not a of n minus 1, and b of n minus 1. That is the last element, right? Okay. This is your correct answer. Now, what is the time complexity here? So, you are seeing only a loop running n times. So, O of n is my time complexity and O of 2n is my space complexity, right? Because I'm using two arrays of length n, right? This is the only thing you need to know about this question, and it is time for us to move to the code now. Alright guys, so here is the coding section as you can see, and before starting with it, I would like to request you to please subscribe to my channel if you are new here, and please do like the video if it is any way helpful to you, right? So let us start with the code. So what I will be doing is, I will be creating two arrays. So vector of int a of size n and similarly vector of int b of size n. Now what will I do? I will say a of 0 equals to 1 and b of 0 equals to b of 0 equals to 1, right? Okay, moving on. What will I do? I will start my loop for I equals to 1. For I equals to 1, I will go up till n minus 1 and I plus plus. What will I do? I will say a of I equals to a of I minus 1 plus b of I minus 1 percentile mode. Why mode? Because it has been given that the answer might be very large, so take a mode of it. So long mode equals to 189 plus 7. Okay, now moving on. B of I is equals to a of I minus 1. I will not take a mode here because it is not necessary. A of I minus 1 already contains a mode value. Okay, now what will I do? I will say return. Now I want to use 189, but I have tested it before. 189 is not working. I have to take the power, I have to calculate the power all on my own because of the n is very large. So in that case, I have to take the mode and then calculate power, right? So power of 2 to the power n minus a of n minus 1 plus b of n minus 1 whole to the power mode, percentile mode of the sum, right? Percentile mode of the sum. Now here is something I want to add, plus mode. Why plus mode? Because the thing here, power can become negative. Why negative? Because of the percentile mode. Again and again I will be doing. Let me show you the power first. Okay, so power is actually long power, which is taking my long a, which is 2 in some cases, right? And long b. Not in some cases, 2a is always equals to 2. Now long answer equals to 1. Now while b is greater than a, b is greater than a, that is that many, b is greater than 0, sorry, b is greater than 0, because I have to multiply it 0 b number of times, right? What will I do? Answer star equals to a, and now answer percentile equals to mode, right? Okay, now what will I do? For the last time I will say a star equals to a percentile equals to mode, and b. What I have done here, what I have done here, Okay, so what I have done here, this is exponentiation. This process is called exponentiation. If you don't know about it, please study about it. This is an important topic. So exponentiation, what does exponentiation do? Let me try to solve it for you on the pen tab. So what is exponentiation, right? What is exponentiation? That is you have to learn, right? So 4 to the power 4. Suppose this is my calculation. What does it mean? 4 into 4 into 4 into 4 into 4, right? Now, what can I do instead of 4 to the power? It can also be expressed as 4 square square. So what will I do? I will say 4 to the power 4, break it down. Break it down into 4 square and 4 square. Multiply both of them and you will get it. Now 4 can be broken down into 4, 4, 4, 4, right? What will you do? As soon as you reach n equals to 1, that is the power equals to 1, you will turn it. So now it is 16 multiplied by 16 and 16 into 16 multiplied by here. So you are saying that instead of 1, 2, 3, 4, I am actually doing 1 and 2, 2 multiplications as well only. 2 multiplications, right? This is called exponentiation. It reduces time. It computes the power in log of n time, whether this takes time of n, right? So just time complexity measure, nothing else, right? So let us move to the code back. So after that, return answer. Let us try to run it. It should run fine, I guess. And talking about this plus mode, this is just for avoiding the negative values of power of 2 to the power. Oh, it is giving an error. What is the error? Mode was not declared. Okay, it is capital MOD. Right, let us try it now, and here it is also capital MOD. Right, let us try it now. It should work fine now, I guess. It is running, and it is running fine. Let us try it for submit as well. It should run fine, I guess. And it is running, and the counter is okay. So 171 day streak. So thank you for watching, and we'll meet again in the new video. Till then, stay tuned and keep coding. Thank you. Have a nice day.